Let's go back to our discussion. You can hear me, right?
Yes, sir.
Yes, sir.
Okay. I don't exactly remember where we were, but I think we didn't go far with IoT. Uh, so IoT basically connects the different devices uh, with the internet, and purposely you use them. Uh, the purpose can be really various. Uh, the applications at this moment are have a wide range, but it will uh, um, broaden, and nobody knows where it will end. So you can use the devices to collect data as sensors, uh, or to actuate something. Okay, so for different purpose, when as you connect the devices, definitely you have to have an IP address. I mean, this part may have been covered in other course. If not, let me just tell you that every device on the internet is identified with an IP address, and the previous version of IP was version 4, had a 32 bits long address, and so the number of combinations you can get is limited. Okay, and IP version 6 was later introduced, where the IP address is 128 bits long, and very interestingly, it includes the MAC address of the device. But anyway, the point is that you can actually assign unique address to any device, okay, with so long address. I do remember we shared this potential growth of the IoT devices. Okay, the market size in billions of US dollars. It's really booming very fast. Okay, you yourself can think of um, starting up a business. Okay, in IoT area. Um, the devices can be wirelessly connected. That's why we are discussing it here. Uh, but it can also be connected through wires. Okay, using Ethernet, you can connect the device, and a lot of times that is done. However, mm, the wireless connection is getting more popular. Um, in the next slide, we'll tell you why. In the first line here, we wanna mention that in this case, you have a connection where at the both ends you have some automations, some computers, or some uh, machines, okay, other than human being, are operating at both ends. So it's called machine to machine communication, or machine type communication. As opposed to that, our uh, normal communication, I mean, when you talk to your friend, is human to human, age to age communication. So if you think of pause or swiping your credit card, okay, you know that at both ends, uh, machines are operating. Okay, so uh, now if it is wireless, then the device advantages are like that you can have the whole thing installed very promptly. and it's cheaper. Then you don't need the wires for the connection, and the devices can be scattered. Many different devices can be scattered at many different places. So if you just use wireless, you don't have to connect. You just place the device. That's it. And also, it can be mobile when it is wireless. Okay. Uh, just to show you that the devices can be for various purposes. Okay. It can be wearables uh, to monitor the cows, like how long they ruminate, the rumination period, or I mean other activities. Okay, of the so smart heart you uh, can have smart agriculture. Okay, uh, in many in smart in industries. So when you use automation and I mean you use IT devices uh, uh, for different purposes, the whole system gets smart. Uh, and you even may use the device for your um, own medical purposes, like monitoring yourself, how long you are walking or you're taking rest. Okay, so the applications are actually endless. um, it's just showing that many different purposes it may attempt to fulfill. Uh, so just a few examples like building and home automation. Uh, it is called, let me write down, when you use the IoT devices in buildings, it is called BioT. It's building IoT.
Sir, could you give an example where IoT is used?
BioT examples are so many. Like when you use, even we have will shortly show you that Ruby already offers in our country automated switching. Okay, so that is an example of BioT. You have this in this area. The development is not new. Um, in different universities like Georgia Tech, MIT, they have uh, smart homes in their laboratories. Uh, for many years, they have been doing extensive research in this area. Georgia Tech, I think, first set up their smart home in their laboratories in the beginning of this century. Okay, so they have been working in this area so much. So as you the enter your house, uh, the sensors, I mean, your own temperature requirement will be sensed, and accordingly temperature can be controlled. And other, I mean, anything that you use there in the building, okay, is included in in IoT. So it's called smart building, smart home. The term smart building is actually an outcome of this effort. In our countries, we are really lagging, but so many buildings have been already built as smart buildings, and many buildings are now renovated and then converted into smart buildings just using so many BioT devices inside.
It's
So
like
these are called,
everything being linked to the Wi-Fi and like they
it,
are
it,
automatically
I mean,
doing their job.
that
Yes.
we will shortly talk about the platform, how you connect. Okay.
Yes.
Uh, Now we are just mentioning that you have this. this is called either smart building or intelligent building. Okay, and lot of developments have been there already in this area. Like a lot of things
Sure,
can
like
be uh, automate automated control inside. Like even the, say it is called heating, ventilation, and air conditioning. HVAC. Is
HVC. Yeah.
HVAC, heating, ventilation, and air conditioning. So that is now in a smart building. It is all controlled in an automated way.
Okay, sir.
The requirements are sensed. The requirements vary, like depending on the number of people, uh, many different things, like the air quality. Okay, it maintains itself, and they show that like the productivity in the work environment increases a lot when when you maintain air quality, temperature, everything perfectly. Okay, so currently in our countries, you know that we all have manual control. Okay, so we feel better, I mean, with our air conditioning system or heating, whatever. But in smart buildings, things are more perfectly controlled. Okay, with their sensed data, and they also analyze the data. The data is not only collected, but the data is processed. It's analyzed, and based on some algorithm, they develop the requirement. Accordingly, they actuate. Okay, so lot of activities are now introduced in smart buildings and smart intelligent building. That's not it. In fact, I did not include this part in detail because that's not, I mean, just to limit my discussion, but the whole concept applies to a city, and the city is called smart city, where you connect everything. I think I may have one slide on that. It's called then smart city. I'm writing down these key terms in the chat box. There are a lot of detailed discussion for each of them, but I'm just including the key terms, like the transportation system is is getting smart. The different buildings are smart. The traffic, okay. So all these things are then connected. Okay, different things are connected together, and depending on the data, or I mean condition at different things, I mean other things are controlled in the smart city. So it's an integrated control. Okay, so things are developing slowly, but different cities, I mean, quite a few cities are already target for fast development as a smart city. Okay, I mean, if quite a few cities are developing very fast as smart cities. Okay, I don't mean to say that there has been very good progress in this area already, but there are a lot of activities. Okay, small. So in your future research work, okay, I just hope that many of you will be working in IoT area, in the development of a smart city or smart buildings or whatever. So you can see that, I mean, IoT devices can contribute to different sectors. Okay, it can be, I mean, healthcare or industries, manufacturing, energy management, like the buildings which are smart buildings, okay, with good HVAC control, are a lot of times also green building. Okay, so that's another concept though. Green building is not directly related to IoT or these technologies, but the green, it rather tells you that you have better energy management. Green building refers to your energy management of the building. The energy consumption in the building is minimized, and that may use renewable energy. Okay, so this sort of concept, when you use, it's called green building. There's an authority, LEED, LEED. Okay, so they certify when you have uh, good type of energy management. Okay, so green buildings in our country, uh, just a few buildings have got LEED certification. So with LEED certified, you have good energy control for your buildings. Anyway, but a lot of times, you know what, the green buildings are also smart buildings. Okay, and or the, I mean, if it is a smart building, then the energy management is done in a very smart way. Okay, so you know the last line is you name it. I mean the sectors or the, I mean, applications. Okay, they are endless. Okay, things will be developing. New things will be added. Uh, what we have in our country, right? Grameen Phone is currently offering basically only vehicle tracking with IoT devices. You can just from your app, you know where your car is located and its speed and other information. Okay, uh, how maybe you have a driver, but you don't trust. He's not very trustworthy, so you want to keep information of your vehicle. So just add this uh, to your vehicle, and I've also included how much it costs currently. So on the app, you can uh, keep yourself updated with all different types of information for your car. Robi is more advanced in IoT services in our country. Uh, I have shown here three, but they have 6 or 7 different types of services. Okay, like they also have vehicle tracking. I was talking about intelligent switch. Okay, that they offer. So from your app, you can control. Okay, you may be somewhere else, but you can control your uh, mm, lights and other operations. Okay, uh, at the at your home. Okay, so asset monitoring, or I mean, you are using using a camera and with remote surveillance, you may be monitoring your baby or whatever. So Ruby has quite a few different types of services. But if you look at, I mean, if you check online, there are hundreds of many different types of services, different types of IoT devices available. Okay, I actually uh, looked at a very good range before and listed more than, I mean, several hundred of different devices that are available worldwide. So what will happen in this, like in a smart city or in an integrated deployment? Different things will be smart, and there will be interconnection wherever you need. Okay, everywhere you don't need interconnection definitely, but sometimes you need. Okay, like how the traffic pattern is going to be. Okay, you may have data from different buildings, and accordingly, your transportation system may be adapted. You may be, I mean, more metro trains you may start. Okay, so from different buildings, you know how the people are when the people are leaving. Okay, so the transportation system um, can. Now about the platform. Well, okay, maybe I come here first. See the uh, technological challenges. There are different types of challenges, like how you allow the internet connection. Okay, for the for it, your device has to be connected to the internet. Okay, then you can use for either collecting data from the device The device may be acting as a sensor, okay, like for parking light control. It may be collecting data, how many cars are there, how many cars are entering or leaving. So the sensors will collect data and send to you. There can be automated control or there can be manual involvement. Okay, so uh, you have, but the device has to be connected to internet. That's the first thing. And so how you use that? Like, so wireless communication is a possibility. Okay, then how you use the power supply for your device? Okay, if it is wireless communication, then it may be running on battery, but that may run out. So what is your plan for power supply? uh, the data, how much the uh, data content you have in the communication, how you process them, uh, the software complexity or interoperability, many different devices. Okay, I'll touch upon it later. Interoperability, technological, like for example, the device that we have considered for Grameen phone service and Robi service. The question can be if the same device can be used on the platforms of both operators, or if you buy a similar type of device, some device you uh, maybe you have gone to China or some other country where you purchased some IT device for intelligence switch for remote control. Now there will be a question whether that will fit in Robi, whether you can use that on Robi network or not. Okay, so these are interoperability issues, scalability. Okay, so anyway, now before I talk further about the challenges, let me show you what may be the possible platform for wireless connection. Okay, so for wired connection, it is Ethernet. You have to use Ethernet cables. That's the option. Okay. For these low cost devices, you won't use, uh, I mean, other options like coaxial cable or something. So it will be Ethernet. Now, at this moment, let me tell you that the basic requirement for IoT devices are quite a bit different from our regular requirement of uh, wireless communication. Okay. Now think of the evolution, the technological growth uh, for mobile communication from 1G through 5G. The key motivation in the early developments, okay, 1G to 2G, 2G to 3G, 3G to 4G, the key developments was the requirement of higher and higher data rate, both because the number of people, number of users in, was increasing drastically, and the individual data requirement was increasing drastically. So both the requirement of an individual and the number of people who are using, both of them are increasing. Consequently, the overall data rate requirement, the total data that you need to provide over, for example, over a particular geographical area was increasing very fast. And to support this rapid growth, the development in the technology was also, I mean, it just wanted try to catch up or keep pace with the demand. And that was the key motivation for the um, migrations 2G to 3G, 3G to 4G. So you'll see that the key achievements there was a higher data rate. But in the case of 4G, to 5G, we probably have already mentioned the diversity of applications have impacted as well. You definitely have a lot better data rate in 5G compared to 4G, but you also additionally support the diverse applications. Okay, and that is mostly, uh, I mean, a contribution of IoT devices. Okay, because of IoT devices, you have most of these diverse applications. Now, in this IoT case, your requirement is typically not a very high data rate. Think of the regular application, like you are collecting data from the sensors of a parking lot. How much data you collect there is just an indication whether the cars are entering or not, how many cars are there. Okay, so very little amount of data you send, and you also send them on and off. Okay, not very often. So the data uh, is communicated infrequently, and very small amount of data. You may be sensing the temperature at the basement of your house, and accordingly some actions or temperature control is taken. So um, y- I mean, you are collecting just the temperature information from there. Uh, and how much data will then be? It's just the temperature reading. Okay, and that may be sent infrequently. So the amount of data is very low. The data rate requirement is very low, and I mean, it's also, if you think of the data sent over an hour, okay, then it becomes even very, I mean, small amount of data, okay, because on and off you send the data. Okay, so the data requirement is a lot different. Whereas for H2H applications, okay, you may be now doing in 5G days uh, video conference, okay, with so many people, so high volume of data that you need there. So it's not, I mean, it's an opposite type of requirement, okay, for IoT device. Uh, but you don't have a good way to uh, recharge the device, because you have so many devices, you just put them at different places, you even don't know where the devices are located. So how you can charge them? You cannot. Rather, you have to use a battery, okay, and the battery replacement may not also be convenient. So a lot of times what you have, so again, I mean, we're discussing the differences in the requirements for IoT devices compared to our regular H2H communications. Okay, so when you have, I mean, this power supply issue, you may end up using a battery that you don't want to replace. What does it mean? It means that you'll be using a battery for its lifetime, and the device also has the same lifetime. So once your battery is gone, you throw away the device, you put a new device. Your device is no longer working, it's out of order, you put a new device. You cannot replace the battery. For this small IT device, so many IT devices you have at your home or at the industry, so it's not possible for you to replace the batteries for all of them, or to recharge the batteries. So rather, just throw. So this way, the IT devices run on a battery for 10 years or even 15 years. Okay, they have IoT devices are said to be, I mean, I mean, in some extreme cases, let's say to have uh, life expectancy of 10 years or 15 years, and just depending on the lifetime of your battery. What does it mean? It actually means that you have to have very energy conservative. The, I mean, there's the second point here. It has to be very energy efficient, very energy efficient, very low power consumption. You have to ensure. So, like your smartphone, even if you put it idle, you know that uh, I mean, so much power is consumed. You at the end of the day, you have to recharge, even if you are not using. Okay, at least uh, in every 2 or 3 days, you have to recharge. So you because it's all consuming power. Even when you are not using, you have left it idle, but it's all consuming. That's how its communication protocols are developed. Okay, because you can recharge. So accordingly, the communication system is developed. But for IoT devices, you need a different type of communication protocol. So it doesn't waste power. Okay, it's more power conservative. This point we'll discuss a little bit how you can improve how the IoT devices are given additional power saving feature. Now come to the first point. For your IoT device, you want very low cost. You may spend a lot of money for a smartphone. Maybe you don't need that expensive phone, but just to show off, you are spending a lot. Okay, it's a matter of prestige nowadays, and sometimes the phones are even gold plated. So I mean, people may be ready to spend a lot for their smartphone that they use for H2H communication. But for IoT devices, they won't spend uh, too much. There is nothing to show off here. Okay. Rather, you may be using hundreds of devices. So you will be, I mean, uh, well, looking for the cost saving option. Okay. And I spend just a just a few dollars, or even just if I mean, not even a dollar. When I spend, I mean, some cents for your device. Okay. So for IoT devices, the uh, cost budget will be a lot different. Here, people will purchase many devices, but each of them has to be very cheap. Okay. But how can we make it cheap? You have to make it simple. Okay. So on one side, for your regular safe, I mean, in 2G, 3G, 4G developments, the uh, whole development was getting more and more complex. Okay, to support better data rate, to support additional features, things were just getting more and more complex. But here, you have an opposite requirement. You want to make it simple. Okay, you want to make it simple to save cost. Well, but when you make it simple, your the strength will also be lower, but that is enough because you don't need high data rate. Why you make the phones more complex from 2G to 3G or 3G to 4G migrations? Because you support much higher data rate. Basically, that is the key reason. There are other reasons too. So you make it more complex for I mean, uh, for the purpose of better data rate. But in IoT devices, you don't need high data rate. You need very small data rate, and you don't you want it cheap. So leave all the complexity. Make it simple. Make it simple so it can support only small amount of data rate but it offers low cost. That's it. So extreme simplicity, okay. Low data rate is fine. Okay. So these are the first 2 points. Then ubiquitous coverage, the coverage like in the basement, you may not be using your smartphone, okay, or in some industries areas, or say people work in mines or something. I mean, in different, there are different areas where you may not need to use the H2H communication, but IoT will uh, offer many different applications for industry purposes. So for even say in the basement, you want to put some IoT devices. So you need actually here the device to operate at a very, I mean, where the wireless coverage is tough, but the signal will have very low power level. Okay, so deepening coverage. Okay, your coverage area has to be wider. Okay, with even poorer signal condition, your IoT device will have to work. Okay, so that's also I mean an additional requirement. Okay, so I mean all these things are different requirements compared to our regular H2H communication. Then finally, massive scale, so many devices you have to deploy. With H2H communication, every person has just one device, one smartphone. Okay. So the number of the density of a smartphone may be at most equal to the density of population. But in this case, so many devices you set up at your home, at your workplace, the industries, okay, everywhere. The streets are all equipped with so many devices. So you need actually thousands of devices, even millions of devices. Okay. And I mean, the density of the device will be so much. So you have to support all this device. In the cellular network, we discussed before that as we increase the, as you need higher capacity, how you think of it, like the growth of the data rate demand. Okay, you need to support. So maybe it has grown. So you add more base stations, okay, and support the and increase the capacity. But here, how the capacity requirement increases. The data rate requirement of a device is very low. Each of the devices very low data rate requirement, but the number of devices increasing too much. Okay, very because of extremely large density of device, you actually need higher capacity in your network. Okay, so the capacity requirement increases, but not exactly, but little differently. Okay, the number of device affect the data, the capacity requirement. Okay, so we have different types of requirements for this. Now let's see, say for H2H communication between 4G and 5G. Uh, this is the data rate expectation, how things are jumping. Okay, so in terms of minimum or maximum speed. Okay, all the things are mostly theoretical here in this figure. Okay, but you see that the data rate expectation is increasing for H2H. Okay, the latency requirement, how long it takes for the data packet to get to the receiver. So these are for H2H communication. But but as you compare with the IoT requirements, things are a lot different. Like here, it's showing H2H cases and also IoT devices requirements. Okay, like if you look at the data rate, peak data rate, okay, I mean the green part is for 4G and blue part is for 5G. You see that the data rate requirement, the peak data rate is a lot higher between 4G and 5G. Now, if you check the number of devices, that's for IoT. Okay, the peak data rate for H2S communication, but number of devices, this arrow represents the difference in the requirements for IoT devices. So here also you need a boost, okay, and 5G attempts to support the boost. In 4G, you see the density of devices, uh, the target density was much lower. In 5G, you try to support this. See, again, if you look at it end-to-end latency, okay, it's mostly for H2H communication. And the overall mobile data volume, that's actually an impact from both H2H communication and IoT devices. In the overall data volume, uh, the H2H communication contributes mostly, okay, in terms of data, but uh, as I said that for IoT devices, the number of devices, actually you have the accumulated data requirement significant. Okay. So it's a here we have contribution from both types of services. Okay. Now we will look at the different platforms available for um, the wireless support of uh, IoT devices. It's not that the mobile communication is only available, but there are few like for, Wi-Fi you can use definitely for connecting your IoT device, and a lot of times people are using that. But uh, but think of the difference in the requirements. Okay, you need more energy efficient solution. So a version Wi-Fi Hello has been introduced, with which on the network the device consumes less power, so it will last longer. The battery will last longer. Okay, and um, Bluetooth also have. Uh, so that is the high speed option. Wi-Fi offers high speed, but there are other platforms also. But you are. This is called the last. In fact, you know what? There is a term called last mile solution. Last mile solution. Well, when you connect something to a network, there are many different hops to get eventually your device connected. Okay. So maybe the server is located in another country, and the submarine cables, okay, are connecting you. So many different hops you have, okay, and mostly they will be wired connection. Now, finally, when your device is connected to the network, it may be connected using Ethernet, or say on a mobile network, it is connecting to a base station. So, so this is the last part where your end device, okay, the device that you use, that is exposed to the customer, okay, to to human beings. Okay, so that is the way it is connected is called last mile solution. So the last mile solution can be Wi-Fi, but you are connecting to a server in Europe. Okay, so there are so many other connection hubs. Okay, but the last mile solution is Wi-Fi. That's how your end device is connected. you may be connected to mobile network. So your last mile solution is your connection to the base station. So here we are showing the last mile solution. Okay, of course, to connect to internet, there are many others uh, hops behind. So the last mile solution can be high speed if it is Wi-Fi, or some other moderate speed solutions like Bluetooth, Zigbee, Thread, JetWave, 6LoWPAN. Mostly they are IEEE um, mm, protocols uh, with different numbers. Okay, like Bluetooth is 82.15. Now, for IoT device, since we have a different requirements of energy conservation, Bluetooth uh, has been little modified, and another version, Bluetooth Low Energy (BLE), has been introduced. Okay, so uh, the early Bluetooth was did not consider this type of IoT requirements. Okay, no, this BLE does. The cellular network, well, has definitely the option to connect your IT device, and uh, the regular protocols for IT device can definitely be used there. But to support that requirement of low data rate, okay, uh, but I mean simpler form and energy conservation, these uh, features are added. LTM, okay, um, we that indicates the machine to machine operation. So I'll show a little uh, I'll show actually a couple of slides on LTM, and we'll also show that there is a uh, there is a feature there in IoT within LTM, okay, which can use very small bandwidth, only 200 kilohertz. Okay, so the data rate will definitely very low, but that is sufficient. However, if you don't have LTE, if you have 2G or this type of uh, deployment, then to support IoT device, uh, um, uh, new uh, development uh, is now available. It is called ECGSM. Okay, so you can use ECGSM where you don't have LTE network. Okay, so to support IoT device, you can add. So of course, the original GSM did not have this feature. It's a new feature now added to GSM, 2G network. Uh, Now, in this case, we are considering the cellular network, which uses high power and long range support. Mm, Now, another option is is a recent development, and these guys are very clever. Okay, they use low power uh, network. Okay, just sufficient for IT devices. This network cannot support H2H communication, uh, and they use very low frequency. So just using a few base stations, they can cover a whole city. Okay, so the investment is very low. Uh, they basically barely support the IoT requirements. Okay, with minimum cost, and that's how they are making very good business. Especially Sigfox and LoRa, they have pervaded so much in the developed world. Okay, the good part of the world uh, is now covered with Sigfox and LoRa networks. So there are a few other operators also. These are some operators in the list I have in this last part, which is called low power wide area networks, LP1. Okay. So the in this list, then and we have the names of operators, not the technologies. The early names were all other names in these two slides are names of protocols or technologies. But here in this last part, we have names of operators. Okay, so they have their own protocols uh, in a clever way they manipulate. Uh, but before I get further on that, let me help you recollect that the growth in the generation numbers also relate to different 3GPP releases. Okay. Uh, in the for IoT support, the way 3GPP developed was like up to release 11. Okay, think of it. So, I mean, LT was introduced in release 8. Okay, when I wrote my book, only release 8 was available. In my last year of publication, release 9 got released, and so I added few things from release 9. Okay, but mostly it was release 8. The release 8 was uh, just I mean that was just the beginning of all LT development. Okay, when I wrote my book. Anyway, so see, you see, up to release 11, there was no specific feature in the 3GPP specifications for IoT devices. So nothing was IoT specific. So rather, what people did then, uh, the simplest options for your regular phones. Okay, I mean all the developments then target to the H2H communication. Okay, so these handheld phones, okay, uh, could also be made with its simplest possible option, and that simplest possible option was used for IoT device. Okay. Now these different types of options are actually categorized using uh, um, I mean, for the phone end, the different options are, um, yeah, I mean, specified with different categories. These are called categories. I may have used the term class and category before. I don't remember, but this was always there. Say in 2G days, there's different classes. Then it was called class 8, class 10, class 12. Okay. So in 3G, from 3G they started calling it category. So I mean different category number represents different level of strength, like the data rate support the phone can offer. These things normally, I mean the general people don't know, but as experts, you should, when you buy a book phone, you should check what its category is, the category number, and then you can check online what its feature is. I mean, for this particular category, how much data it can support, its strength. So the support has to be there both from your network end and your phone end. So category number refers. In release 8, there are 5 categories, category 1 through 5. And in release 9, 3 more categories are introduced. And mostly people developed phones with category 3, category 5 in the early days, okay, early days of LT. Anyway, category 1 was the simplest option. Then, okay, category 1 was the simplest option. And that category 1 was used when people wanted to make anything as IoT. IoT means a device that you don't allow for human use. It will be used in machine to machine communication. Okay, a device that connects to machine. There is no, I mean, human being using the device. Okay, so it's a machine type. I mean, I mean, device for machine type use, or what we can also call IoT. So people used to use category 1 then. In release 12, people first introduced some UE category or phone category, specifically with IoT requirement. How's that? I mean, it is simple. Okay, it has, I mean, it will be cheap. It is simpler than category 1. So it offers low data rate, but it is simple. It is more energy conservative. Okay, so you have uh, an option, or you have IoT specific development for the first time in 3GPP release 12. Okay, then in release 13, people further develop. So the dev developments, okay, in these releases are identified with these terms: MTC, then enhanced MTC. In release 14, they call further enhanced FEMTC, and in release 15, it is even further enhanced in EFEMTC. Okay. So mostly, I mean, the new UE categories, okay, helped a lot. So in release 13, you see M1 and NB, M1 was introduced. In release 40, M2 was introduced. Additionally, this look at the NB1 and NB2 options. In this case, the bandwidth is only 200 kilohertz. The regular LT deployment has the lowest bandwidth. The permissible lowest bandwidth is 1.4 megahertz. Okay, the bandwidth can be different: 1.4, 3, 5, 10, 15, or 20 megahertz. These are the 6 options available in LT. So whatever UE category you use, whatever IoT device you use, the whole bandwidth in the operation will will be that wide. Okay, but I mean, the bandwidth that the device uses is low, but the overall bandwidth that it has to deal is wide. Uh, Now, if you make it small, okay, then it is sufficient. Actually, the data rate will be very low. So in NB1 and NB2 option, the overall bandwidth that it works, that it looks at, that it captures, okay, is only 200 kilohertz, and it also operates, or it uses for data transfer. This is small bandwidth, 200 kilohertz. Okay, so in the case of UE category 0 or M1 or M2, okay, or in 1Bs, okay, that's also a development in release 14. So you don't have that small bandwidth of option. So things will not be that simple. So NB1 and NB2 are the simplest options, are the most cost-effective options. Okay. So especially NB1 is currently the most potential IoT implementation. Okay, so the data rate is, you see, is low, but it is the cheapest and most popular option. Okay, I mean, for the future. Okay. The requirements in the industries are just here tabulated for different types of actions. Okay, like motion control, mobile robots. Okay, so you see that the total payload has only a few bytes. Okay, tens of bytes, indicating how much data you may need. Okay, but it has to be very reliable. Availability has to be very good in the industries. The number of devices is shown at the last column. Yeah, you need good density. Okay, now uh, how you may achieve good energy saving. Here it's also showing the development EMTC, FEMTC, EFEMTC. Okay, so when you consider the development in the NB-IoT devices, people often use the term also. Okay, ENB-IoT, FENB-IoT with the later releases of 3GPP. Okay, okay. Now I will discuss how you can make it more energy conservative. Well, there is an option called discontinuous reception. Okay. By the way, you uh, what time is it? Okay, we have 10 minutes. I think we can finish. For our regular phones, okay, we have this feature, discontinuous reception, and it has been there all the way from the beginning, from the 2G days. Uh, it is to save power, even for our human use. uh, for the handheld device, we don't uh, want to charge it very often. Okay, we need power saving to some extent. Okay, and to save the power, what the phone does when you are not talking or you are not browsing, you don't have any activities, the phone turns off itself, and periodically it wakes up. Okay, so like this, it has an on period, then an off period, again an on period. So this is called discontinuous reception, DRX. In the off period, it is turns off all the circuitry, the RF circuitry is turned off, the phone saves power. Now why it does so? Well, you're not doing anything with your phone, so why you keep it on all the time and wasting power? So you can turn off sometimes. Then why you wake up? You wake up because you may receive a call. When you receive a call, the network will send you a notification. It's called paging. Let me write down this term, paging. These things we will discuss in detail in the cellular communication course. Right now, just let me tell you a few things. The network pages, or the network sends a paging notification that tells that you have a call to receive. Okay. You never know, the call can arrive anytime. So on and off, you need to wake up and listen to your network. So that is why in every DRX cycle, you wake up once, and in the on duration, it listens to the network. The network knows when you are awake. The network configures the DRX cycle, how long it should be, how long the on duration is. So the network sends the paging notification during the on duration for yourself. And so if you get a call, then uh, the activities start. Okay, the DRX stops, rather the data transfer starts. Okay, now this DRX feature is enhanced in the case of uh, IoT devices. Okay. To support IoT, okay, now this DRX cycle at the maximum can be 2.56 seconds. Okay, in the ordinary case for your phone, the maximum length of DRX cycle is 2.56 seconds. Now to support uh, IoT device, extended DRX has been introduced. In this case, what is done, in addition to this wake up, okay, I mean DRX cycles where we have on duration in every cycle. In addition to that, you have a group of um, cy- DRX cycles with a gap in between. Okay, so this is an example of EDRX cycle. So what happens that you um, use a number of cycles and you wake up in the on period, but you see that there is no call from the network. Then, well, you assume that, okay, I may not be receiving any call shortly. So rather, you sleep for a long period. And then after this long period, you again use different rounds, okay, like before. So these are called hyperframes. These are called hyperframes. And you, I mean, how many hyperframes you want to sleep? So you set up the actually the network sets, but the phone recommends that I want to sleep this many hyperframes. Uh, the hyperframes are 10.25 seconds. So see that in the ordinary case, the DRX cycle could be 2.56. Okay. But here the hyperframes are 10.24. So a number of hyperframes it will sleep. So like here, it is showing that you have n number of hyperframes it is sleeping. So after this n number of hyperframes, there will be again normal DRX cycles. Normal DRX cycles in which you wake up in uh, uh, every cycle, okay, for the on duration. The with these hyperframes, you have a long sleep time, and the maximum sleep time can be 43 minutes for LTM devices. I mean, the M1, M2, those options, 0, M1, M2, or 1 bis. For these options, these are your LTM. These are all LTM devices. But this NB1, NB2, these are special types of LTM. So if it is LTM, then you can sleep up to 3 hours. And for other LTM devices, the maximum sleep time is 43 minutes. Okay. So that you can sleep longer. And in this case, I mean, when you woke up, you found a page message indicating some call. Okay. So the normal data transfer then continued. RxTX means you're receiving data, you're sending data. Okay. So definitely you have either you have made a call or you have received a call through paging. Okay. So some activities data transfer occurred here. Thereafter you again, once it is complete, you again sleep. Okay. Uh, so that improves the sleep time and so saves the battery a lot more for IoT devices. Okay. Of course, this is not available for H2H communication. Uh, then another option with even better strength is available, which is called PSM. Okay. In this case, you your device just goes dormant. Okay. Uh, but before going dormant, it negotiates, uh, and the network allows the uh, phone to go dormant, and thereafter, I mean, so an example can be like you may be collecting some data annually. Okay, so you have a device which will send you some sense data annually. So the device can go dormant, and the device knows it has some timer inside, and okay, some logic or timer. Based on that, it knows that it, it has to transmit after so many days. So it can go dormant, but it will still be registered. Your device will still be registered. So it is not turning off everything. It is not detaching. So when this whole wait time is over and you need communication, then you transmit. Okay, and you'll have. Hey, by the way, you were there, right? So it's 10:30. You could, okay.
We're here, sir.
It's 10:30. So
Yes.
can I take 1 or 2 minutes?
Yes, sir. Sure, sir. No
Okay.
problem.
So so in this in this PSM mode, this is called power saving. You can see this slide, right? Power saving mode.
Yes, sir.
Okay. So after the dormant period is over, the device first transmits, and the network comes to know that yeah, that device has again now become active. Okay? So thereafter, there will be normal operation, and there will be some cycles like when the network can page you. Okay, so you have some on periods. So after after the dormant period is over, the device transmits, and that's how the network is notified about its presence, and the operation then resumes. Okay. So after some operation, it can go again dormant. So this way, the maximum sleep time can be more than a year. It can be even 413 days. Okay. So if you need, say, some annual operation, or say operation biannually, okay, every 6 months or in every 4 months, or monthly operation. Say you have a meter, energy meter, or meter for utilities, water or whatever. So where you need to collect data once a month. Okay. So the device can just go dormant and then become active once a month and send the data. Okay. So that's how it can save the whole of your its energy. Okay. So the whole purpose is battery power saving. Uh, I have just a few slides left, which we'll discuss the next day, inshallah. Questions?
No question, sir. So, like, if you could give a example from real life how the IoT is working,
Uh,
relating to each other, sir, like, would be very helpful.
like the energy meter example is I would say the most widely deployed example these days. Okay, I mean, for and like I use some uh, list of operators. I mean, Sigfox, LoRa, and few other operator
Yes, sir.
names are there.
Yes, sir.
Some of the operators use only utility mm, devices. I mean, devices for reading data for the utility purpose,
Yes,
like
sir.
water meter or energy meters. Okay,
Yes, sir.
so it's a I mean good example,
Of
but
course.
for IoT, the examples are endless. I mean, maybe I should be able to list. I mean, uh, list many. Okay,
Yes.
uh, promptly, uh, but that's difficult for me. But you see, the vehicle tracking,
Yes, sir.
asset monitoring, okay,
Of course,
for
sir.
security purpose. Okay, you can use. I mean, you may not be at home, but your security devices will be there, and you can You can check from your app how things are
Understand, sir.
there, okay,
Yes.
and you can get notification when there is a burglar or something.
Okay, sir. Okay,
Okay,
sir. Okay.
and so I mean the possibilities are endless.
Yes, sir.
There will be billions of devices in, I mean, very shortly in this area. Okay,
Yes, sir.
anything else?
No, sir.
Okay, uh, actually had a slide at the end. Maybe I showed that. Just give me a second. The last slide I had, okay, was like this. Okay, okay. I
Okay.
couldn't finish
Yeah.
my presentation today.
Yes,
But
sir.
the IoT that we are thinking of these days is just a tip of an iceberg. Okay.
Yes.
Okay. With that, let's finish today. Oh well, we need to have our third class test. Okay, we are lagging too much. I'll also publish your scores. Anyway, so I'll talk to the seers.
Yes, sir. Please do, sir. Yes.
Yeah, schedule third class test. Okay. Thank you.
Okay.
I'll see you
Thank you, sir.
tomorrow.
Okay.
Thank you,
Assalamu alaikum,
moderator.
sir.
Alaikum assalam.
Assalamu alaikum, sir.
Assalam.